So thank you very much for coming. My name is Ian Goddard. I'm the lead software development engineering test for Playback at DAZN. Some of you may have heard us, we do sports streaming. So that puts me in a fairly good place to talk to you about that. There'll be lots of sporting things in all my examples, but don't let that put you off. So in terms of video playback, and I said it was there, the problem is that everybody seems to think that video playback stops at it's just playing. And that's fine for a lot of products, but for some products, that's a real problem because you might be able to do very, very small amounts of testing and make that product a lot more resilient. In order to get through to that, today we're going to have a brief talk glass-to-glass overview. That's from camera right the way through to your television. I'm going to talk about the differences between broadcast and what's called OTT or over-the-top services like Netflix, like DAZN, like Hulu. There, like every other region of testing, there is an awful lot of three-letter acronyms, so we'll be going through some of them just to make sure that we're all on the same page and we know what they are. Then we'll talk about the more challenging areas and the things that we actually need to get into, the meat of what we test on top of it's playing. We'll talk about playback in the microservice world, as well as what's going to happen towards the future and things that we like there. So a very quick overview of what broadcast used to be. You used to have, let me play with this because they gave me a laser pointer. You used to create the content, it would come into your studio, it would get compressed and what's called multiplexed. This is a satellite, as I'm sure you can all tell. It would get put up to the satellite through the transmitters, back to your satellite dish in your house, to your set-top box or your television and your projector or whatever it is there so you can actually see it. This was the same workflow whether you were using your satellite dish or you were using the cables from your cable network or you were using the analog signal broadcast out. And that looked like this. So we're already into horrible scientific diagrams that don't make sense, but this is it's actually a PAL signal. It's phase alternating line, and that's what you guys had here in Lithuania. Most of Europe had it. We had it in the UK as well. There's also another one called NTSC, which is mostly sort of Americas, some in Japan as well, and another thing called CCAM, which was French, and some of the Russian stuff as well had that. And what would happen here is you have a 7 megahertz span across here, and you'd have some video, you'd have the white balance, and you'd have the audio. And that's all you could fit in was just that one service. So as you can see, we're wasting a lot of space in this spectrum. So in that 7 megahertz bandwidth, you had not very much information. And that was a real problem for people. They really, you couldn't have anything apart from just what you were watching just then. There was no information about it. There was nothing you could do. Then we moved on to the digital age, and that's what this is. This is what's called DVB-T. I've listed them out there. Here are the flavors of the digital variety. That's digital video broadcasting, terrestrial, cable, satellite, in that order, and the kind of sleeker, younger brothers that are T2, C2, and S2. DVB-H was a handheld variety. It was they originally made it as an idea that you would all be watching television on your phones. That's not how we do it. That's why I'm here talking about OTT, so that one you can kind of forget. ATSC was the one in the Americas that replaced their previous brand, and ISDBT, same for Brazil and Japan. And what we have here is each one of these little squares is a 7 or 8 megahertz bandwidth, and so that was the entire picture we had here represented in just one tiny block here. And what this would do is, we've got a lot more information there. There's a lot more that we can pack in there. So suddenly we were able to put in subtitles, EPG guide data, so you can see what was coming up or what's happening. Timings, you started putting in alternate audio tracks. Lots of things suddenly went in. So it suddenly became a lot more stuff that we could throw out. And so that suddenly became the standard. That caused a few problems before we had the switch over. We're now, I believe you guys are as well, most places in Europe are fully digital. But when we existed in a world of both analog and digital, we had these horrible clashes where these multiplexes here and these analog signals here caused chaos for each other, and they pulled power and they pulled information, and you ended up with a really bad signal on every channel, which was just awful. Which is one of the reasons that we led to the OTT revolution, stuff we have with Netflix and Hulu and DAZN. That's a little bit different because we're doing everything via the internet. So we have our live event, and all our data comes in here, so that goes into our encoding comes to our streaming server. It gets pushed all the way through to our live to VOD recording. We'll go over live to VOD a bit later. And fundamentally, it just gets pushed out through our CDN to whichever device you're currently looking at. Now, we'll talk about CDNs in a bit more detail a bit later because they are quite complicated. But also, the added bonus that we had here is that you could push it out to syndication. So suddenly, you could sell the rights to what you were making for no money at all out to YouTube, Facebook, Netflix, DAZN, whoever wants to buy them, they could all put them out. So, and you have it stored. It's completely stored in the digital realm, so you can push it to wherever you like. And obviously, you know, now we've got all of these different devices all looking at it. We can look at it on the move. So digital was a great step. OTT was an even better step. In order to do this, we have what's called adaptive bitrate streaming. Some of you may notice when you watch things online that the quality will dip at various points. You'll suddenly, you know, you'll have a really crisp, high-definition image to start with, and then it will dip down to something that's kind of unwatchable for a little bit, and then it will come back. And that's due to the ABS, adaptive bitrate streaming. As it says there, it's a streaming protocol. It just detects your bandwidth, it does it in real time, and it adjusts. So if you have a bad time with your internet connection, it'll adjust so you still see an image without actually, you know, losing anything whilst you're at lower bandwidth. The way that it does this is everything is chopped into small segments. So your content that you're trying to watch is typically between 2 and 10 seconds, and that is listed in a manifest file. All of these things we'll talk about in a sec. Stored on a web server, and it's served to you as it's requested. This makes it really easy because now instead of giving you a whole hour content, now we've got stuff in little 2-second bursts. We can change as and when the bandwidth allows. So how does that work? This slightly clunky diagram, we have a 1 megabit segment. Oh, that's my WhatsApp, sorry about that. Probably going to happen again in a minute, but just ignore it. We also have a 512 kilobit segment here, so we have 2 renderings of the same piece of content. This gets pushed and chopped into little segments described in the manifest file, which is just here. And we have the 1 megabit and the 512 kilobit for both values for every piece of content there. So every segment has both renderings. When we get to your telephone or your web application or whatever it is that you've got, your client will find the manifest file first. That is very, very important, and we will talk about why in a sec. Now you've got loads of bandwidth, you download that first segment, and you've got the 1 megabit, and it's great. Let's say it's 10 seconds. So you watch 10 seconds of content, and it's really, really great, but then all of a sudden somebody else jumps on your bandwidth and takes your current usage down. So now you can't actually get that 1 megabit anymore. What happens is the manifest realizes the bitrate finds the lower one, and it serves you this content. So now the quality dips, but you still see content. Now you haven't recovered, so your next segment's going to be low. Now that person's finished doing whatever they're doing on the internet, and now you've got loads of content again. And this will just keep going for the entire length of what you're watching. So it's very, very useful that it'll just adapt as you go, and it won't have buffering, and it won't stutter and be horrible. We've all experienced that at some point, I'm sure. So it's not particularly great. Now, the manifest files, they're served up in 3 main flavors. It's HLS, which are the M3U8 manifests, Dash, which is the MPD, and MSS Smooth Streaming, which is ISM. Now they're made by our friends at Apple, Dash Industry Forum, and Microsoft. These are the kind of industry standard ones that you'll see. They get broadcast with every bit of content. There are a few others. They're not really used very much, so I haven't really touched on them here. The thing about the manifests, they describe the stream for the player. So before the playback can start, the player has to consume that so that it knows exactly where to find all of the segments for what it's watching. They've got information about the codecs for audio and video. It also it also defines the encoding ladder. So everything that we saw there for the 1 megabit and 512 kilobit, it defines how many of them there are and what it can give you. It also indicates the DRM technology. Now that's very, very important. And again, that's another slide in itself. We'll talk about the DRM keys as well. They're all pretty simple. They're just sort of basic XML files. There's nothing too complicated in them, except Apple HLS because of Apple. They have to do something slightly different, so it is slightly different. But again, it's not that dissimilar. So it's basic structure XML, which is not too crazy. So we mentioned DRM, and that's digital rights management, coming in the flavor of PlayReady, HLS Fairplay, and Widevine. Again, in this order. It's content protection, so it makes sure that you as a broadcaster can protect your content. And it does this by setting what it's called a secure clock for itself, as well as preventing screen capture. So if any of you find any content that's got DRM protection on a browser like Safari, try and take a screenshot, and you'll notice that what happens is it gets blacked out. And that's the DRM sorting that out. Now, in order to do that, you need to talk to the DRM server and get a valid license for that. Now, that's a little bit more of a complicated issue. It's not really what I'm going to cover in this. But this is the basic chain. So it gets transcoded. It goes to a separate DRM packaging manager. This then goes through our CDN to our origin store. Again, we will cover what CDNs are in a bit, which then gets delivered to your device. The device then has to contact the relevant DRM license server. So if you were using Widevine, for instance, you would have to go and contact the Widevine license server. It's a pretty simple database. It's looking up, it's a yes, no, is this user allowed to watch the content? There are some slight quirks in the rest of it, but fundamentally that's kind of how that works. Now, one of the most important things about OTT delivery is the content delivery network, the CDN. Now, I've actually ripped this straight from Wikipedia because they said it way better than I could. You provide content fast, and it's highly available, and it makes things much easier, much more accessible, because without a CDN, wherever you're serving your content from, if you were trying to push it through the internet to every single user, if you think about Netflix and how many users try and access that same episode every day, that's an awful lot of computing power that you've got to do there. And it's all coming from the same origin, and that is going to get really messy really quickly. So with a CDN, what we have is we push the content to one particular location, and it serves it out. So we farm out all the content that we have to push out to other locations, and that makes it a lot easier because then we don't have to deal with it. We can let another party deal with it on the load in a particular location. Now, that really helps when you see this map. You can visualize it that this is the origin. This is where, it's not where we are now, but like this is where my origin server is. And we push it out to what's called the CDN edge servers. That's all these blue ones, as you see here. So instead of having to, this user in India tries to access our content, he doesn't have to contact us all the way in New York or wherever that is. I can't really tell, but now we can get somewhere here or even here, and it's much, much closer. And that means that they will not put pressure on our servers. They'll put pressure on the CDN servers. It's a much better idea. It's much easier because things will come much, much quicker. Now, that's really important geographically. The next picture, I like showing it because it demonstrates a point, but also because I think it's probably one of my favorite pictures that you can find. And this is the internet, the undersea pipelines for the internet. So you can see how many connections there are if somebody in India wants to pick up something from someone in New York. It's got to go a long way, right? And every time you have one of those interchanges, every time you have a little switch, you introduce the potential for errors. And that's really bad in an OTT world because errors are the worst thing that you can possibly have. You'll stop people watching, so it's not good. But it's a good map. I think I like that. Might be slightly out of date now, but still serves a point. So we have an example of Hulu. So everything that we've just talked about, this is from 2016. Not much will have changed for them to now. They don't care about anything on the left-hand side here. They pick their content, much like Netflix do. They pick their content and they put it onto their systems. What they then do is they package it up with the HLS-packager, and that gets pushed to its CDNs, which gets served to the public. On top of that, they have their metadata and their manifest generation for a variety of different formats, and they chuck a bunch of different data into the metadata to the client gateway. That gets pushed. At the same time, they actually do have their ad server, so if you're on their non-premium account, you do get ads as well. That's another quite complicated system because then you're adding a whole other layer in as well. And then once it gets here, we check the digital rights system, make sure they're able to view it, and that's when you get your content. So we can see OTT is already quite a lot more complicated than broadcast. Broadcast used to be just one signal, beamed out. If you received it, you decoded it, it was fine. Now we're talking about a lot of different moving parts. So that suddenly becomes a tester's nightmare or dream, depending on which way you want to go with it. But I think we can all agree that now there's a bit more than does it just play. There's a lot of moving parts there. The other thing to pay attention to here is that back in the day, broadcast was live. Everything was live. You couldn't really have any recorded content until we switched to the digital. However, when you've got VOD content, it's all completely stored. It's fine. It's pre-edited. Maybe you're the first person onto a CDN. That's very unlikely, but if you're the first person there, it might take a little while for you to get served your content as things warm up, but there's really not going to be too much of an issue there. You're also only going to have one single manifest as long as that CDN holds. It doesn't change, and then we're absolutely fine. And crucially, there's low customer pressure. So when you log onto your Netflix and you go and watch that, you actually don't mind that much if you wait for a couple of seconds to watch something because you know it's going to come there. That's not a problem. At the end of the day, you end up pretty happy. The problem with that, with the way we do things at Design, where we will put live sports out. Now, live has a lot more problems because you can have multiple manifests. It could be a new one per segment. You could be switching CDNs every 3 seconds, potentially. Doesn't happen, but good. You have latency. So every single one of those interchanges that we saw earlier on the pipes introduce latency, which is a very, very big problem for video playback. And you have very high customer pressure, not just because it is live, but because sports fans are really angry. And they like things to happen now, and they like to know things now. Now, the challenges with latency, that's, like I say, the very, very big one. So these are all things that will introduce latency into your product. And that's before it's even reached your customers. The player policies too are pretty important because if your buffering rules, your playback positioning, or it's just not very resilient, it'll fall down, it'll introduce its own latency in there. So then you have yet another layer of latency there. So latency is a really big problem, one that really does need to be addressed. These are the estimated latency times that we have for the 3 currently latency packages for OTT. Now, what's important to note here as well is when we had broadcast, we had what was called the broadcast delay. And that was between 6 to 8 seconds that was on every single broadcast. And the reason for that was because you didn't want somebody doing something stupid on live TV. You didn't want wardrobe malfunctions. You didn't want swear words and all that kind of stuff. So there was an inherent built-in 8-second delay. And nobody knows that. So when you think you see live TV, you don't. But the problem is with OTT, that's not built in anymore. So now when we say, the latency needs to be, next to nothing, people forget that they were never watching live content. The only way that you watched the actual live content of that football match was to be at that football match. Now, you need to account for it in your testing because even the reduced latency at the lowest point, you still have 6 seconds there on average. So you're still, even though statistically you are matching broadcast, you're still going to have a problem because sports fans are angry. They don't want 6 seconds. How many people, by a show of hands, have ever been somewhere where their television was lagging behind their neighbors and they were hearing the same thing where they heard a goal and then you saw it? Well, there's a few of you there. Yep. I know your pain. So really kind of the benchmark, what we're looking for now is the ultra low latency down at 0.2 seconds. Now that doesn't sound like a lot, and it'd be great if we can all get there, but realistically, ultra low latency is only getting 82 seconds. And that's kind of fine for some people, but it depends, again, with sports, where you have people who care about stuff on a minute level. They really, really care. A case in point is NFL fans. Now, I'm not picking on any NFL fans, but you guys are pretty dogmatic when it comes to knowing stuff at the same time. You want 3 or 4 games. You also want everything to be at the same rate. You don't want to be able to lose stuff on your fantasy draft because suddenly something is a bit delayed. It's a very complicated thing, but yeah, it's really important. So I can't stress enough, latency, huge thing to test, really does need looking at. Another thing is AV synchronization. Now, AV synchronization is a big problem, primarily because our brains are wired in a particular way. So I'm going to be really mean, but if you watch this, on some of the other talks I've seen, you'll notice that when you hear me and what I'm doing up here doesn't quite match up occasionally. And that's only just a few steps up to the projector. So imagine what's going to happen if I'm now pulling this from the Bernabeu. That's in Spain, for anyone who doesn't care about football. It looks really weird because you're seeing me and you're hearing me, but up here, you don't see me until you've heard what I've said. And that is really difficult for the human brain to deal with. And now I've said it, you're all going to be watching it, paying attention, so sorry about that. Glad it's towards the end of the conference, it doesn't ruin anyone else's. So it's really, really important to test this. We like, one of the examples I like to use is if I stood here and dropped a basketball and you saw it hit the floor and then you heard it, your brain would be fine. If you saw me drop it, you heard it, and then it hit the floor, that would be a bit weird. And your brain would tell you that was weird. And then you'd be uncomfortable for the rest of the thing, as you're going to be with that, but sorry. The other thing to think about is load. That's the same for any application. That's not specific to Playback. You really do need to simulate real-world environments here. How many people are you expecting to reach from each CDN? If you're expecting one person, that's fine. If you're expecting 10 people, obviously that's 10 times the load. I'm not going to lecture about load. This isn't a talk about load. But it's very, very important. So you need to test on the concurrency and your load. You're testing your CDN edges so that you don't end up like this. You end up like this man who's done exceptionally well to get that all on there. Let's sink in for a bit because it's absolutely insane. The other thing to think about is localization in territories. Now, where are you actually planning to push your content to? How do the network conditions vary? Now, I do not know the network conditions in Lithuania. I'm sure someone will tell me whether they're good or bad later. But they will be different to what's in Russia. They will be different to what's in Australia. Whatever you're getting on your average might be something completely different to what I get. So I might get a really good service when I sit at home, but you don't because you have something slightly different in your network conditions. Very importantly for sports, for DAZN specifically, do you have legal restrictions with the content that you're serving to the targets? So one thing for DAZN is that we buy the rights for specific sports in specific countries. So it's very important that we don't leak content to another country that we don't have the rights. So that's a real big one. The other thing to think about for other legal requirements are closed captions. For instance, in the States, it's a legal requirement to have them on anything that's got speech on it. So will you be broadcasting in the States? Get yourself some closed captions. Another thing you need to think about within the Playback. Accessibility, again, this is not a talk on accessibility. If you want that, there is a whole thing to think about with accessibility. It is a massive topic, one that you really do need to look into. Loudness, huge one in the States. Again, I'm not picking on the States, and I apologize for our American friends, but loudness was a big thing there. There was a big problem with broadcast television where everybody who made adverts made them about 3 decibels louder than the regulations allowed on the programming, which meant that when you had your program on, you had a nice quiet bit, everybody's very nice and sitting down doing nothing. And then all of a sudden you had a Gatorade advert which just hit you. And it was so loud. And the idea was very cynical by the ad manufacturers. They did it to wake you up, to get you to buy Gatorade. Again, not picking on Gatorade. But so now there's regulations in place. There's some here in Europe. There is some in America. There's some being pushed in Italy. And that's very, very important. As well as ad insertion, as we said, if you have that. Error rates too. CDN rotations. These can happen. They're really annoying. They're things you need to test for because it can break players. API responses. Again, I'm sure you're all very familiar with API responses. Third-party errors. Now that's really important because as much as we don't want to have to rely on third parties and we don't want to have problems with them, they do occur. So it's a bit of a problem when it does. I put meteorological and geographical in there, but I'm yet to be able to simulate a meteor strike or anything. But if anybody can, please do let me know. And you end up with that horrible page again and again and again. The other thing is quality of experience. Now, quality of experience you need to make sure you're not confusing with quality of service. Everything we've said about so far has been quality of service, and you control that. The quality of experience is what the customer sees. Now, this is going to be, I'm running a little bit behind, so I'm just going to have to rattle through this, but by show of hands, would you watch that? No one. Fantastic. Good. You're all on my side. How about that? Yeah, we got a few people. We got a couple of... there's some things there. It's not too great. I've done a poor job of cutting it off as well, so, you know, that's error between user and the machine. How about this one? Would anybody watch this? Nope, straight no. Nice. Is that a no because it's the bikes, or is it a no because it's so bad? It's blurry. That's good. How about this one? This one? Yeah, see a few more hands. This one? I realized there was very little action in these. This one? Yeah, a few of you. Okay, so let's move away from the GP. Would anybody watch this? Yeah? Nice, just watch a field. That's fine. How about this one? Anybody watch this? There's a few others of you, yeah. How about this one? How about that one? Yeah, ooh, an audible intake. Ooh. So the point that I'm making is that some of the qualities that you've just seen are what are defined as high definition video. And some of the ones that you've said no to for the the MotoGP, sorry, are actually higher qualities than this, and vice versa. Just because something says it's high definition doesn't mean it's going to work in the same way. You know, for instance, I picked this one because grass is very, very hard to get high definition on. It's notorious for it. We use it as testing videos all over the place. Sometimes, you know, what you think you're putting out as a high definition video will not be received as a high definition video. It is very tricky. In a microservice world, I'm just going to rattle through this quite quickly because I think you all know what microservice world is. Small individual services that all get put together instead of a mono repo. Again, this is not a talk about microservices, but can Playback fit in there? Can we be full stack? Absolutely we can. Playback is at the front end, it is at the back end, and it is also upstream. So you actually have a lot of things going on there that you need to cover. I'll wait when some people want to take some photos of that. But the big question then becomes, what do you want to test? And this is nothing special to Playback. This is exactly what you'd expect for everything else. How long have you got? What do you care about? The two questions that I would ask any project manager, any business owner, anybody who asks me to do testing. How long have you got, and what do you care about? It's no different to any other area. For the players, you care about the UI. Do you care about the decoding and presentation of video? I know I said it's not about whether there's a video and it just plays, but that does still matter. Please still do those tests. Do you care about the APIs, the manifest schemas, the DRM? These are all things that are external to us, but CDNs, encoding, integration with the app. Now, you should care about that, but if you have a dedicated Playback team, they might not care about that. It's definitely worth looking into. You must test the integration because your app could be perfect in isolation, and then you put a player in and everything goes to hell. So it's not great. The other thing to think about is devices. Everything I've been saying has been to do with the web. They are then reflected again in devices that come with their own problems. It's madness. And the other thing to think, and I'll make friends or enemies with this one, I'm sure, is testing in production. Now, this is Kazimir Zeglan, and he is the man who invented the bulletproof vest, and he is far too happy about being shot. This is in 1923. It's the Chicago Police Department. They are testing it because they were going to buy some for their officers. And he's fine. He's happy because he knows it works. And the reason he knows it works is because he had to test it. In 1901, he tested it. Not himself. He got his butler to do it. So, if you can find some patsy to let you shoot them, test in production. But you do need to do it. The other thing is utilizing the cloud and the chaos QA. We have a lot of that now. Lots of talking about the cloud, serverless. We as QAs need to go with that. Playback is no exception. Cloud is the future. System faults are inevitable. It's highly vulnerable for playback. And you must embrace the chaos. So you start using, I know some of these are out of date now, but any of the Simian Army tools, any of the chaos engineering tools definitely will help you. Build them into your pipelines. And this is why. Because this is the state of the microservices for Amazon and Netflix in 2016. Imagine what they're like now. It's chaos. Utter chaos. So embrace that chaos. Kill things. Kill things left, right, and center and see what happens, because your chain for playback is huge. You have a load of moving parts. Go and kill them and see what happens. Resilience. You must have resilience in there. You will have these failures. They will happen. Kill them and see what it does. Make sure that you're doing... I'm not going to lecture you about chaos engineering. I wouldn't say I'm an expert by any stretch, but go and figure out what you can do with your systems back at home. And my final thoughts, you can't test glass to glass. It's not plausible. You can physically do it, but this comes back to our question of how long have you got? You know, it's not plausible, so focus on what's important to you. If that's just the player itself, you stay with the player. If it's subtitles or captions or whatever, have a look at them. Test as close to the real world as possible. Be the man with the gun. Don't be the man with the bulletproof vest on, but be the man with the gun. And test in production. Take that, go with it. Embrace that chaos. Always embrace the chaos. Now this one's it's controversial, because as testers we inherently don't trust anyone, but you kind of have to. You have to take a step back and say, hey, look, actually I've got to trust the guys that do the CDNs and the data centers, the encoding guys. Otherwise you will go insane, because there are so many bits that you need to look at. The other one to say as well, automate. It will not solve everything that you want to do, because there is so many stuff in playback that you just cannot automate. It will never replace a person whose eyes are looking at a screen. Yeah, that's me. Thank you very much.